Hey guys, here's section 9.5. Continuing on our theme of circles, we're going to talk about angles formed by tangents and secants. So the angle has to be outside the circle because you're going to have a tangent, which is of course outside. Secants can go through it, so your angles are going to be outside the circles. So the measure of the exterior outside angle will be half the difference of the two intercepted arcs. Okay, so you think about that as you're writing it down, half the difference. So you got to subtract and then cut it in half of the two intercepted arcs. So let's say you have a tangent and you have a secant. That's one of each. You're going to take the measure of angle 1. It's going to be half of the bigger arc minus the smaller arc. That's between the angle there. So big arc minus the small arc divided by 2 equals your outside angle. Big arc minus small arc divided by 2, which is times a half, same thing, equals the angle. If you've got two tangents, then you need the big arc, which is this part of the circle, and you need the small arc, which is the other part of the circle. The whole circle's in between the two tangents. So it's your bigger arc minus your smaller arc, and then you cut it in half and you get the angle outside. That's when you got two tangents. What about if you got two secants where just part of the circle's in between? You're going to take your bigger arc minus your smaller arc and divide it by 2 or cut it in half and you'll get your outside angle. So that's your three options here. You got a tangent and a secant, one of each. You got either two tangents or you got two secants. So let's see if we can find the measure of angle 1. We are going to take the big arc minus the small arc and then divide by 2, and that's going to give me the outside angle. Timesing by a half is the same as dividing by 2. So the big arc is 204 degrees right here. The small arc is 84 degrees. So if you subtract the big arc minus the small arc and then divide by 2, that will give you your angle. 156 divided by 2, your angle 1 is going to be 78 degrees. That would be this angle outside. And you can pause it and you can copy it down if you need to, but we're moving on. Here are two challenge problems. I would love you to pause the video right now and give these a try and see if you can solve for x before I show you how to do it. If you can't, then just keep the video going and I'll show you. I'd really love you to try it though, see if you can figure out the value of x in each one of these. They're a little bit of a challenge. Alright, so the first one, you've got your big arc is 200 degrees. You've got your little arc is x, and you've got your 72 degree angle. So this time we actually have to use the formula to plug in the pieces that we know. This time we know the exterior angle is 72 degrees. We know the big arc is 200. We know the small arc is x, and we're going to divide by 2. My next step would be to multiply both sides by 2 to get this fraction to go away. So if you times both sides by 2, you're going to get 144, and then you'll just have the 2's canceling out over here. And then if you subtract the 200 and divide by -1, you'll get a 56 is going to be our x. So this is a 56 degree arc. Now you could always check your answer. 200 minus 56 is 144, divided by 2 is 72. So it does work. That would be your first challenge. Pause it, try the second one, see if you can get it. Alright, first thing I want to show you right here is that the big arc is the entire circle minus the smaller arc. So the big arc from M through L all the way to N is 268 degrees. That's your big arc. Your small arc is 92, and your angle's x. So again, your formula, x, your angle, x, outside angle, big arc minus small arc divided by 2. 268 big arc, 92 is the small arc, divided by 2 equals your angle. 176 divided by 2, and you get 88 degree angle is what you would have right here. X would be 88, so you'd have 88 degrees. Alright, moving on. When you have intersecting chords, two chords that intersect, and there's no diameter or radius or anything like that, just two chords intersect. Two chords intersect inside of a circle. The measure of each angle is half the sum of the arcs intercepted by the angle and its vertical angle. That's a lot of words. Now, I would, when you write it down, just try to look at it and understand it. But when you look at it, you might understand it better if you see the little equations here. Angle 1 is going to be the sum of CD, which is one vertical angle, and AB, which is the other vertical angle. So you add those two arcs together and then divide it by 2, you get the angle 1. Angle 2 is when you add these two arcs together. Where the vertical angles are, you add the two arcs together, AD and BC, together and divide by 2. So what is another way that we could say this theorem? Well, here it is. Each vertical angle is the average of their intersected arcs. Average of their intersected arcs. So you add them together, add the two arcs together, and divide by 2. Add them together, divide by 2. So here's an example. Let's try it. The vertical angle arcs divide by 2. So you add the two arcs together and divide it by 2. So you get 146 divided by 2, which is 73 degrees. That would be your x. Vertical angle arcs divided by 2. On this one, we're gonna put y right in here. This is x, but we got to find y first because they gave us the two arcs for y. So 104 plus 106 plus 174 divided by 2, that's going to give me the angle y because the vertical angle is the same there. So y is going to be 280 divided by 2, which is 140 degrees. Now this 140 plus this x makes a straight line. They're a linear pair. X and y are a linear pair. Since they're a linear pair, that means they're supplementary. 180 minus 140, x is going to be 40 degrees. So this is going to be a 40-degree angle there, this angle x. All right, deposit if you need to. Moving on. Intersecting chord lengths. So now we're not dealing with the angles of the chords. We're dealing with how long the chords are. So here's another theorem that you could write down and have in the box. Two chords intersect inside the circle. The product of the lengths of one chord equals the product of the lengths of the other chord. It'll make more sense if you see the little equation, EA, and look at it on your picture, times EB, these two pieces, if you multiply them, equal these two pieces, if you multiply them. So easy enough, we're just multiplying and solving. So if this is x and that's 18, and that's 12 and that's 9, simply do x times 18 equals 12 times 9. These two pieces equal these two pieces when you multiply them. 18x equals 108, therefore x is going to be 6. So this x would be 6. 6 times 18 is the same as 12 times 9. Same thing over here. X times 9 equals 3 times 6. 9x equals 18, therefore x has to be 2. So a couple of quick examples there. All right, moving on. Lengths of two secants with a common point. So this time you get, it's like the big arc minus little arc divided by 2. If you were trying to find this angle, that would work, but we're trying to find out how long this piece is, or how long this piece is, or the length of this whole secant right here, from E all the way to D. So to do that, two secants share a point outside the circle. The product of the outside piece and the whole piece of one secant is equal to the same in the other. Now, it'll make a lot more sense, and I would read it over, try to understand it before you look at the equation, but if you can't, here it is, here's the equation, this will make more sense. EA, this outside piece, times the whole thing, EB. I'm going to tell you right now, the tendency is to do EA times AB. This piece times this piece. That's what all students like to do. It's not right. It's EA times EB. The whole outside piece times the whole piece. Outside piece and whole piece. So EC times ED. So notice how it's common E's. You got to use common E's here. Okay, so here's a couple examples then. We got outside piece times the whole secant. Outside piece times the whole secant. So what we do is the outside piece is 11. The whole secant is 21. 11 plus 10 is 21. So it's 11 times 21, not 11 times 10. Outside times whole amount. And then the 12 is the outside. The whole thing is the 12 plus x, or you could put x plus 12. So then you just simplify 231, you get 12x plus 144, and you solve that and you get x is 7.25. That's how long this piece would be right here. 7.25. Now for a secant and a tangent length, it's almost identical to this formula up here. You're still going to be using the outside piece and the whole segment is equal to the outside piece and the whole segment. So in other words, here's the formula that makes sense. The outside piece is EA, the whole thing is EA. So you're just going to do EA squared. So it's the same as we did over here, outside times whole amount. Outside times whole amount are the same, so you just square it. Outside is EC, the whole thing is ED. So again, it's outside times the whole thing. So EC times ED. So let's try a couple of practice ones on that. And again, you can pause it to get that written down there. All right, let's try a couple of examples. The outside piece is 24. The whole thing is 24. So really, it's just the tangent squared here. So 24 squared. The outside piece is 12. The whole thing is x plus 12. So again, you're just going to distribute. You're going to square that. You're going to subtract 144 on both sides. You're going to divide. You're going to get 36 for x. So this x piece right here would be 36. That's just outside times the whole amount. The whole tangent equals outside times the whole secant. Now there's two secants. So the outside piece times the whole piece. So the outside is 9. What's the whole piece? Think about it. The whole piece is not 11. The whole piece is 20. That's 9 times 20 because 9 plus 11 is 20. The outside piece is 10. The whole piece is x plus 10. So that's your outside piece and your whole piece. So just multiply and distribute 10x plus 100. And then you get subtract 100. You're going to get 80 equals 10x. And x equals 8. All right, and don't forget your practice problems. Very important. There's some of them there. They're on your paper. And there's some of them there. They're also on your paper. But don't forget to get those done. See you guys later.